Welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap today, lots of great information, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it later on and watch it on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll get to as many as we can near the end of today's webinar. Okay, with that, we'll go ahead and kick off today's webinar, which is Orchestrate Your End-to-End Mainframe Application Release Pipeline. We have a full house of speakers today. They include Mark Schettenhelm, who is product owner at Compuware, Steen Brahe, and I apologize for mispronouncing your last name, who's product manager at Compuware, Scott Erlanger, who is senior product marketing manager at XebiaLabs, and finally Vincent Lessenberg, who is director of DevOps strategy at XebiaLabs. Welcome, gentlemen. Thanks for joining me today. Mark, I know that you are going to kick off today's webinar, so I'm going to put myself on mute and let you get started.
Thanks, Charlene. Before we get started, we wanted to let you know about a brief survey opportunity that will be available at the end of this webcast. We value your feedback and appreciate your responses because they help us provide better content for you. By completing the survey, you will be entered into a drawing to win one of 3 $50 American Express gift cards. I'd like to start by introducing Compuware. Now, Compuware has a history with the mainframe that goes back decades, and it's really focused on, in the center there, the DevOps. So it's the debugging, the testing, building, edit, deploy, analyze, and tuning, all those things that we've done for the mainframe for decades. But really, what we're going to talk about today is our focus on helping you mainstream your mainframe. We, along with our partners like XebiaLabs, work to open up the mainframe. You benefit from new tools and technologies that work across platforms, which transforms the experience. I'd like to turn it over to Vincent to introduce XebiaLabs.
Thank you very much. What I will be speaking right now about is a little bit of the introduction, basically why we think this webinar is especially relevant in this time and day. And specifically, I want to quote things from the 2019 Accelerate State of DevOps report. So this is a large-scale research that's being done by an independent research group that takes a lot of effort to basically undergo an investigation with scientific rigor to really see where the industry as a whole is basically in their state of transitioning to more faster software delivery, and as well seeing like how much of DevOps is actually something that's just nice to talk about versus the real tangible benefits that we're seeing. And we'll be able to relate some of the 4 key metrics that they discovered in this webinar as well. So first of all, talking about the software development lead time, it's very obvious that one of the things that we want to do with DevOps is we want to go to production more often. We want to have a lead time from the idea to actually being able to deploy it in production as quickly as possible. And this is completely relevant in the distributed world as well as in the mainframe world. What you see in this report is that basically all the respondents have been divided in various different groups from low performance to elite performance. And what we see as well is that basically only so far, only about 10% of the respondents take into account mainframe development. So what we see here, can I go back? Sorry. Yeah, let's stay on this slide for a while. I'll tell you when to transition. So what we see here is that there's a lot of opportunity for some of these metrics that are going to be valid for both distributed world and the mainframe world. to be rolled out to using some of the technologies that we're about to present to you. So one of the things is, of course, lead time. You see a difference between like the low performance to elite performance that you go to production, about 208 more times between those groups, 106 times faster from commit to deploy. Actually, 2,600 times faster recovery from incidents, and only a 7 times lower failure rate. So there's a couple of things going on. Normally, if we look at these metrics, we think that they're trade-offs, right? You have high lead time, but then you have a low time to restore or a high time to restore. Your failure rate is high, but your deployment frequency is low. Any of these things. So what they discovered is actually they're not trade-offs here. So you can actually improve all of these 4 metrics at the same time. What you typically do see is though that your failure rate is not orders of magnitude lower than it was in basically a pre-transition state. So what we learn is that actually by going faster, by creating a process, a standardized process that gets you in production faster, you still have failures that are going to happen. Again, to requote that, the failure rate is 7 times lower, but that's still a lot of failures or a reasonable amount of failures that you see in production. But creating big releases doesn't really prevent that much. So what you'll get as an advantage is the ability to recover from incidents so much faster. And in order to do that, it's really important to automate as many activities that you have in your pipeline. And to look at a couple of these different things that we can automate, like to go to the next slide. What the researchers basically have taken a look at, compare that low group to the elite group. So what are the activities that they're already automating? So all these activities that allow you to go basically faster, having a pipeline to basically give you these various benefits that lead into real business results as well. What we see is and again, keep in the back of your head that this is a combination of both the mainframe world and the distributed world, so basically all the software development. We do see that automated build and automated unit tests are actually pretty high across the board already. Like even the low performance, there's a good number of people that are already doing that. But what we see is that in automated acceptance tests, that there's actually a lot to be gained. And what we see as well is that there's a big difference between the low performance and the elite performance in how much deployment to production is actually being done in an automated fashion. So just to set the stage and why this is an important topic to talk about.
Thanks, Vincent. So, pulling this all together, this slide basically shows you on the left what are some of the best practices in DevOps, and on the right how these things tend to be done on mainframe releases. And as you can see, they're quite different. Best practices in DevOps tends to have end-to-end release pipelines. It has integrated testing of all the tests as part of this pipeline. Things are automated. You do several releases a day. While mainframes, things tend to be separate. You have a separate pipeline for mainframe releases, which isn't really tied into the rest of your software. Testing is all manual. Handoffs are manual too. So you rely upon specific people to do the checks, to receive the handoffs at different stages within your release. And the biggest problem is that mainframe software releases tend to be a bottleneck. As was shown on the previous slide there, that Vincent was talking about, removing this bottleneck will make your organizations more efficient by helping your mainframe software releases be more like your best practices. But I think the bottom line, and what we're going to show throughout this webinar, is that it doesn't have to be this way. Your mainframe releases can be as efficient as all of your other software releases, and it's XebiaLabs, along with Compuware, that helps bring this DevOps to the mainframe. Next slide. So first, a little bit about us, for those of you who may not know us. XebiaLabs, we've actually been part of the DevOps movement since the very early days. And it's our sole focus on DevOps and continuous delivery, and we've been repeatedly recognized as a leader by top analysts within this space. Our customers are across many different industries, and they're some of the best known and best run companies in the world, from financial services to retail, manufacturing, all the way to the public sector and government agencies. Organizations come to XebiaLabs to help with their overall DevOps journey, as well as with some specific concerns. They may be looking to move applications to the cloud, add continuous integration to their overall release pipeline, or ensuring good governance, compliance, and security for every release. One area that strongly benefits from continuous delivery, but may not come to mind immediately, is with mainframe software releases. So this webinar in particular is going to show you how to mainstream your mainframe releases by incorporating them into your software release pipeline. This slide here, which is going to be a build slide actually, shows you a bit about our XebiaLabs DevOps platform, which is essentially our end-to-end release orchestration and continuous delivery deployment automation platform. So release orchestration, the one thing that we do, which is key, is that we connect all tools automatically with no scripting whatsoever. So you see a sample of the tools shown there above. These are connected through the release orchestration pipeline through our integrations, and we support hundreds of them. So all of your favorite DevOps tools are supported by our platform. You can deploy to any environment of your choice. You can deploy on premises, to the cloud, to mainframes. We support these. So you have a flexible way of deploying your software to the place where you need to run it. And one thing is that across your entire end-to-end release pipeline, we gather all the data that you need. So you have a single source of truth for all of your compliance, security, and metrics reporting. So you can tell what happens, when it happened, and who did it across all different stages of your release pipeline. You know, this is pulled together as part of security and compliance dashboards. You can have automated one push button audit reports, value stream metrics, so you can continually use this data to improve your release processes, as well as predictive analytics, so you can tell before it even happens whether a release is likely to have any failures or encounter any issues. And as I said, this is the XebiaLabs DevOps platform, which includes top-ranked DevOps technology and is built for enterprise use, and it scales across your applications, you know, as your business grows. It uses features such as model-based, agentless, dual mode, as well as it includes ease of use features to help, you know, automate your releases. And XebiaLabs is actually the only end-to-end DevOps toolchain and orchestration and reporting platform.
And I will continue now. I'm Steen Brahe, Product Manager for Topaz for Total Test, and I will introduce you to the scenario and the demo of an automated DevOps deployment pipeline that we will now show. But before doing that, let me just show you a general DevOps toolchain slide that we in Compuware use to show how Compuware products together with our partners' products match into perfectly into a modern DevOps pipeline, development pipeline. And this goes all the way from creating ideas to writing stories over to, as a developer, using a modern IDE to develop, edit, validate, and debug your code, versionize it with version control system, generate, execute test cases, deploy your application to production, and when it is in production, how you can monitor and measure your application in production and feed that data back into your development process, completing the DevOps circle. So today we will look at how we can use version control. So as a developer, how you can versionize your code, how you can create and execute unit test cases with Topaz for Total Test, and finally, how you can set up a deployment pipeline with XL Release from XebiaLabs that can orchestrate the execution of test cases and do an automated deploy with ISPW deploy mechanism, so you get your changed application into your production mode. Next, please. So let me be a little bit more concrete of what we are going to demo. So we will using a a batch application that is working on employee information. And more concretely, we will be changing one program. It's a called COBOL program. And what it does, it calculates and generates compensation reports for employees. So what it is doing, it is reading an employee file with records about employees. And based on the employee information, it might calculate compensations for this employee by calling two different submodules. And finally, it will generate a report file. Next. So what we're going to do is we will start having Mark showing how he can make a change to the program inside Topaz, Compuware's IDE for developing mainframe code. And then he will commit the change into ISPW. Then we will see how Topaz for Total Test works. We will introduce the product and show how you can generate and execute a unit test case of the changed program. And finally, in that part of the demo, show how it can be shared in a version control system like Git, so it can be then reused in an automated deployment pipeline that can then execute the test cases. And that will be the final part of the demo. It will be Vincent from XebiaLabs that will show how an Excel release pipeline can look like, that will integrate with Git to check out test cases created by Total Test. Then it will use integration with Topaz for Total Test to kick off these test cases. And finally, if these test cases are a success, it will then execute an ISPW deploy mechanism that will deploy the changed load module into a production load library. And this pipeline will be triggered when the developer, after having made the change to the program, committed to it to repository, and made the test cases, the developer will then do a promote of the code to the next stage, and this will trigger the deployment pipeline. Next. And just to show how this looks like from a graphical point of view, so after the two first demos, when the developer has made the change to the code and versionized it, when the developer has created the unit test, the developer will then do the promote to ISPW from within the Topaz workbench. This will trigger the XebiaLabs pipeline, and as you can see, this will then integrate with Topaz for Total Test to execute the test cases, and finally do the deployment with the ISPW integration. So first, let us switch over to Mark that will take you through how to use ISPW to do versionizing mainframe code.
Thanks, Dean. ISPW is a modern mainframe CI/CD solution. It enables you to automate mainframe source code management, build, and deploy. It supports agile DevOps by enabling concurrent development for mainframe apps, and also uses webhook notification and REST APIs to help you build an automated pipeline, as we'll show today. It also leverages modern Eclipse and web interfaces. So let me show you ISPW. This is ISPW within our Topaz Eclipse workbench. I'm going to start with down at the bottom here where we have what we call an assignment. An assignment is just a work area that you go and put the programs or JCL, whatever you're working on, in. In this case, I put the program that Steve mentioned, CWCT COBX, in there because that's what I'm going to be working with. And I'll keep it in here as it moves up through the different levels, which are shown up in the top left, where I can see the life cycle. Now, at the top, we have the code that's in production. I have taken this from production, the copy of that source, and put it down into my Dev1 development environment. And as you can see, for this application, and for every application, you can have a different life cycle, but for this one, I have 3 different paths. So I could work in Dev 1, someone else could get a version of the code and put it in Dev 2, and someone else could even put it in Dev 3. And as they go forward, we can then go into separate QA areas, so we can do our testing there, and then finally we merge them up into the staging area before they're put into production. If for some reason, while everyone's working on that, we had an emergency fix that needed to go in, for this application, we defined an emergency path where you could pull it into fix, go into emergency level, test it out there, and put it into production. All these would have approvals if needed before they go on. And in between levels, you can also, using the webhook notification and the REST APIs, have other processes. So to the right, we have some more information on this program, and we can see that it is a subprogram. As Steve mentioned, it does have two called subprograms. All this is available to me before I go in and start to work on the program. So let me go in and work on it, and I just double click on it, bring it up, and I can see I have my editor here. It's all color-coded, and I can work with my code there. But I also have Topaz for program analysis installed. And what this does is, as you saw, automatically analyzes the program as soon as I bring it up. So here I have a structure chart of the program, so I can see how it's laid out. And I can click on that, and it will sync to where I made my changes. Now, in this case, I've added some logic here that's for setting regions. So north, east, south, and west. Added that logic, put it off into this separate paragraph, and I have it there. When I select that, I also can see information on the logic flow. So I can go through and see how that particular paragraph is laid out and walk through the logic step by step. When I'm satisfied with this, and also I can check here and see if there's any problems that we can detect with our parsing. If I think it looks good, and I do, I didn't detect any issues here, I go through the logic, it all seems tight. What I would then do is go back into, click here to ISPW, and I could then go in, and let me just get out of that program, and I could generate. So that would compile that program. So I just click on that, it will go off. It's a mainframe process to go and do the compile, and that gets it ready for testing. And then I could, when ready, promote to the next level and go on. But before I do that, let me turn it over to Steen, who will talk about how I will set up my testing and automate that.
Yes, thank you, Mark. So before I, as a developer, will show you how you can create and execute a test case related to this program, let me just start introducing you to what Topaz for Total Test is. So Topaz for Total Test is a tool from Compuware to test mainframe applications. It is built into our Topaz IDE development environment like ISPW is. And what it can do, it can create and execute test cases, both unit test cases, functional test cases, and integration test cases. Today, we will only look at unit test cases, but let me just explain what we mean with these concepts, because everybody seems to define testing concepts differently. So unit test is something a developer does. It's the developer that understands the code, looking into the code, understanding that now we have a new if statement, and the developer that wants to test that if statement. So the developer is in control, and when creating a unit test, as a developer, you are able to stop out or virtualize all external calls from your program. So a unit is the smallest possible unit you can test, and for a COBOL program, that is a program. So you're testing a program as a unit, and you can externalize and virtualize or stop out all these external calls. And this way, as a developer, you have the power to decide what path in your source code you're going to test. And this is what we're going to see. With Total Test, we can stop out all calls to data that is both files, it is database access, and it is execution of subprograms. And if it is a CICS or IMS program, we can also stop out and virtualize the CICS and IMS API calls. So you are in complete control and completely isolated. Functional test is when you're testing your load module as a black box. That is typically a QA role that will test it by providing input and expected output data. And it is basically a specification or requirement definition you're testing of your program. Integration testing is then when you're starting to test the collaboration between two or more programs and the data they use. But I will not go into more details about these. We will concentrate on looking at unit tests. Next. So before going into the demo, just quickly to explain, Topaz for Total Test is a modern way of looking at testing on the mainframe. It is integrated very well into a modern DevOps development process. So as a developer, you will sit in a modern IDE and develop and debug your code. When you want to, you can then start to generate or create test cases. And one thing that is unique here about Total Test is you can actually automatically generate a test case. So you can, of course, create a test case manually by defining all the stops of all your external dependencies. That can be quite hard if it is a data-intensive program, but from a runtime execution of your program, you're actually able to generate a test case and generate all the stops that has been used as part of that execution. And that is what you're going to see. Then you can execute your test case, you can review the result, you can actively use code coverage together with Total Test, so you can make sure that you actually get into the right path of your program. And finally, when you're ready, you can share your test cases with any version control system you want, and then in this way integrate the execution of the test cases into a DevOps pipeline that we will see today with XebiaLabs Excel release. With that said, I will now show you a demo. I'll just show my screen. So now you should see Topaz Workbench, and so this is an Eclipse-based tool, and inside Topaz we have Topaz for Total Test installed, and I have opened the perspective of Total Test. So I already have created a test project for my program, the demo program that we're looking at, and I also already have generated one test case for this program. So what I want to do now, I want to create another test case. And the way that I can do that easiest is to submit a job on the mainframe that will execute the program. And for that, I will use Compuware's debugger on the mainframe called Expediter. So I can launch an Expediter debug execution from the Expediter perspective. And what will happen is a job is submitted at the mainframe. Expediter will monitor it, and it will open up the source code inside the IDE on my machine. So this is the way that a developer normally would start to debug the code. So this is nothing special to Total Test. So I could, as a developer, now start to debug, and I can see it automatically set up a breakpoint at the procedure division of my source code. Expediter knows all about the runtime, so it knows what data was sent through the linkage section of the program, and it can monitor the execution going forward. So now, as a developer, I will not debug my program, but I just right-click and I choose Generate Test Case. And now I can choose where to save. So I select the existing project, the existing test scenario, so it will generate a unit test into that test scenario. And I click OK. And now I tell Expediter to resume the execution on the mainframe. So Expediter will now continue the job, but monitor the execution. And for every time the program calls an external resource or reads something, Expediter will know about this and record the data and save it as a stop. And during the execution, I'm using another product from Compuware called Runtime Visualizer. So at runtime, I can see how my program interacts with other resources. So I can see it reads from the employee file. So every time it reads a record, I can actually see that. and I can see when it calls any of the submodules that are used. And I can also see that it opened up a report file that when it has completed the calculation, it will write the records to the report file. So this will be running, and when it's complete, it will then create the test case, the new test case in my test scenario. So let me switch back to the total test perspective, where we will see that it will change my test scenario when it's complete. So this test project containing my test scenario, we can see that it has an annotation. It says app employee tests master. This means that this test project is shared in a Git repository. In this case, it's actually in GitHub, public available, so you can go in and look at this if you want to. And another thing we can see is there is a stubs folder. So the stubs folder contains plain files with all the data that has been recorded through the execution of the program. So for instance, you can see the employee file for the first test case. I can open that stub file, and you can see all the records that were read from the sequential data set that this program is using. And that means we have all the data necessary for the test case in this test project, and meaning that the test case is completely isolated from the real environment. So now it has completed. It shows me a report, and let me just, I close this stub editor. I can open my test scenario that we can see now contains 2 test cases. So I select the new one, and what I see here is an input data tab where I can see the recorded input data to the linkage section of the program. Then we have an assertions tab that shows the recorded output data of the linkage section when this was recorded. So this will be used as assertions. So when I execute this test scenario, this test case, when this test case executes, it will visualize all data from the program and ensure that the data that this program then returns when it is being executed will be the same as the value that we recorded here. Final thing is the stubs folder, the steps tab. We can see the selected stub files that will be used when we execute this test case. And this way you can decide for a specific test case, either use what was generated, but you can also go in, change these stubs manually. So for instance, go into another path in your program and test that and include these stubs in this editor. And when you're ready, you simply hit execute. You select what LPAR to execute at, and you click OK. And the difference now is, now we're executing the same program, but in contrast to before where we recorded the test case where everything was running live, now everything is running virtualized, meaning the program is executed the exact same way and the program gets the exact same data as before, but now it is from the test case itself, from the test project itself, where we have a consistent set of input data and the expected output data. And when it's complete, it will show a result report, and we see the success rate is 100%, and we can see that it did nearly 600 assertions. And this means it's not only testing the values of the linkage section, but it's also testing internal state verifications of the program. For instance, it verifies that the report file generated contains the same data as it did when we generated it. So that was a quick walkthrough how to generate a unit test and how to execute it. We really didn't go into details about how all the possibilities you have of manipulating these tests. That must be another time. Last part of this quick demo is I can now open my Git staging area. So this is not part of total test. This is part of Git. I can see all my changed files. So I can say, well, I want to add these to my project. I can give a commit message, and then I can commit and push the changes, which will push them to GitHub, and then they are available from an automated DevOps pipeline if I created this such one. So that will be the next stage. So next part of the demo. So this is the time when I will hand over the word to Vincent from XebiaLabs that will take you through how to set up an automated deployment pipeline.
Excellent. Thank you so much. That was awesome to see again. And indeed, let me take over here. So I want to set the stage just before I do my demo. I want to go over like a couple of things that Scott already mentioned, what XebiaLabs does basically in the context of all that we've just seen. We're going to look at the product actual release that's able to do the release orchestration for you. So what the focus of that product is allowing you to design, basically to visualize and to run all of these different steps in the right order in a release and enterprise pipeline that can take you all the way from planning to running in production, to operating in production. What I will be showing you today is our integrations with ISPW and Topaz for total test, seeing how a release was triggered basically by the work that Mark did in ISPW, it being a version control system, and XebiaLabs having integrations in basically all the version control system. We can trigger off that, see that there's change, see that that change is in a certain stage, in this case QA1, which in this case would trigger the QA pipeline. What we want to do as well is we want to automatically execute these tests that were just what we just saw in the demo of Green, that theme that it created, that basically they're executed on the various stages as well. And then finally, as we move forward in that QA pipeline, actually trigger a deployment to the specific LPAR as well in an automated fashion. So what's the advantage of that is that we're not specifically waiting for an operator to do this. This is something that's automatically executed for you, basically in combination with other different integrations that we might be doing. There's a couple of examples that we see in that overview there. The advantage is that not only you see what needs to be executed in one order, you get an audit trail as well. You get handling of failures. I mean, what would you do if something goes wrong, for example, with running one of these tests, or code quality? All of that ends up in basically an auditable fashion. And to refer back to this metric that I was talking about earlier, that actually allows you to gradually go faster in your releases and basically get the benefits that DevOps really is promising to you. And that's like true for any environment you do it in. So I think as part of that, I'm going to take over the screen share now. Let's see, choop. And if everything is going right, you should be seeing the overview in XebiaLabs' release orchestration product right now. What we see right here is the release that was triggered basically by the changes that Mark just did. And let me go over what we specifically see here right now. This is basically a visualization of all of the steps that we want to do. And the demo here is really focused on the QA pipeline, right? But in context as well as all the different other steps that might be happening all the way towards production. So our technology focuses on visualizing all your different steps, and flow is top to bottom, left to right. So all the different steps that need to happen, that need to be done to make sure as when you actually go to production that you're sure that what you're putting in production is exactly the thing that you want, that you went through the right processes, that you run your tests, that you did your deployments, that you maybe did your performance tests, your security scanning. What we focus on is giving you an overview of all of these different activities in different overviews, depending on the background of the users. It might be more useful for them to see them in tabular fashion. You might really want to see them as a Gantt chart, seeing where you're spending all of your different time, doing your different planning. But basically everything points to the same thing, all the activities that need to happen. We see a lot of automated activities, for example, checking out the test cases, and then this is basically the project that was just committed, as well as running the tests within that. Those are automated tests, which we momentarily will see the moment that I click the Start Release button. You see as well as, for example, automated code checks. So, for example, what was mentioned before, when these unit tests run, statistics get calculated, that gets pushed to SonarQube, which has information on code coverage. And this is something that we can automatically check with SonarQube, for example, to make sure that the program that we're releasing is actually meeting that code compliance, so that there's no apparent mistakes that were made. This is not just true for security. This could be extended to, what I said is not just for quality, but that's true for security as well. For example, checking for security violations. And there's many other activities that you could sprinkle into this overview, which will be executed automatically, doing Jenkins builds, creating Jira tickets, interacting with ServiceNow, for example, creating change requests. Do want to really focus on what we wanted to show here, which is focused on that QA pipeline, doing that automatically. So I'm going to go ahead and start that release, and we're going to see how XebiaLabs orchestrate that for us automatically. So what we see is it checks out the test cases that were just created and is running Topaz for Total Test to actually run these test cases end to end. As it did that, we can open up and get information on what exactly was done. So if I click here, I see basically all the different information, the parameters, how I ran that test scenario. You can control various things. We saw the use of stubs earlier, so we can right here indicate if we want to use those stubs, or do it against the live environment, what we want to do with the statistics that ties into code coverage. And of course, we see all the output of the run that was basically done. So all that activity is actually captured right here. It's recorded in the audit trail. We see that at this point, there's nothing that I needed to do. It cleaned up the workspace automatically, reached out to SonarQube, made sure that our program didn't introduce new code quality violations, and then moved to the other LPAR and basically checked out the test cases again and ran the unit tests at the different environments. So we have our pre-checks that were done, basically a duplication of what was already done in the workbench before, but now we have that evidence right here, and running that information again in context of that, the right LPAR here, with the stubs again. We see that the process right now is halted. So this is a manual activity right here, just a placeholder so it doesn't automatically continue. But what you can see here is you can have a combination of, for example, executing these unit tests automatically, then doing a distributed deployment as well. So since our platform integrates with all these different technologies, being it distributed system, cloud, containers, mainframe, we can have a single release process where we're pushing an element maybe from that employee program onto, for example, a WebSphere environment. It might be a Kubernetes cluster, as well as interacting with ISPW, which doesn't only do the source control for my program, but basically controls, creates a release container for me as well, with information on how that program is to be promoted. And as well as I can trigger a deployment on a specific LPAR for that, which we did. In this case, that is an overview of all these different activities that happen in our QA pipeline. Oftentimes, there's still some manual testing, manual checks that you want to do in addition to those unit tests. So this is something that can be planned in XebiaLabs as well, where in this case, at one point when you're done with that, you can go ahead and complete, and then the process will continue. So you see this combination of automated activities as well as manual activities. And like I mentioned before, all of that is captured in an activity log, which I can filter basically based on all these different parameters. So everything that happens in context of that release gets recorded. This is very important, first of all, to make sure that the progress is measured, and we have dashboards as well that show you in context of the release exactly where you are. So we see that one release was created in ISPW, see that basically there's a planned deployment and a completed deployment. So you have an overview of everything that's happening here, where we are in context to the pipeline, which is configurable as well. So this is really focused on giving you the real-time visibility where you are. What we're able to do is generate predictions as well. For example, if there's a high probability of this task not being completed within the time allotted to that, you would see that right here in the UI as well. Slack messages can be sent, emails can be sent, etc., etc. So all these activities can be orchestrated. I'm going to go, although our focus really is in like QA pipeline, right? We really want to see how we can automate quality assurance a little bit better with the use of ISPW and Topaz for total test. I'm going to continue through the production release as well, mainly because I want to show you as well the fact that once that release is completed, we can generate a release audit report. What that release audit report does for us is, instead of something that is just a reality of things that we tend to do in the enterprise space where we are, instead of having to write that audit report, it's something that's generated for you automatically. So what we see here is basically all that activity of that release. You can zoom into the different task details. You see all the timestamps. You see specific deployment information, security and compliance information, for example, that Sonar Cube check. So this is really focused on giving the auditors right away all the information that they need. So you don't have to compile that for yourself, which is quite important. Want to finish up by showing what kind of information you get as a dashboard level as well, because you can imagine we've been looking at one release, but you can imagine that an organization is running many of these different releases. There's many different business units. So what we make sure is that we visualize insights about the different releases that you're using, either for a specific business unit. So this is at a folder level. So this is all related to this demo that we're doing right now. So we can see what has been happening with my releases efficiency over time. What's the percentage of my automated versus manual activities? And there can be focuses on basically what your goals are there, as well as it will show you where you're spending the majority of your time, what kind of releases, what phases take you the longest. So this is on a sort of a business unit level. And then ultimately there is that information across the entire enterprise as well. So you can see filtered by time, how am I doing in my releases, where can I improve? And all of this is really important to basically select, contrary to what opinion of a couple of people might be, to actually have data on where you're spending the majority of your time. And what I often see working with my customers is that that's often not what you initially expect it to be. Only what we have as well is release value stream information. So this is just detailed information on all the releases that you have been running, with detailed information on where did I spend everything, where did I spend the majority of my time, with all the details of that run specifically. What I would be able to see as well, for example, this is a release that had a lot of errors. So that is something that it's really focused on reporting on. And as I zoom in on that, on an historic release, I can see why it failed, what the problems were, and this is something that I can learn from in the future. With that, I would want to indeed give the screen share back to Kim.
Let me summarize what we've seen today. Analyzing and editing code with ISPW and Topaz for program analysis, unit testing and how it can be automated with Topaz for total test, how XebiaLabs XL Release automates your entire software delivery pipeline from development, tests, to releasing to production. Now, we've focused on just a portion of the total tool chain that you see here, but which also then covers things like ideation, data management, code quality, and performance monitoring. But we want to do a focus just on some of those things that are more towards the center today. Before we move into the Q&A, we wanted to remind you again about the brief survey opportunity that will be available at the end of this webcast. We value your feedback and would appreciate your responses. By completing the survey, you will be entered into a drawing to win one of 3 $50 American Express gift cards. Also, we have more in-depth information available at these links. And then I'll turn it over to Charlene for the Q&A.
Okay, great. lots of good information, which means we've gotten lots of great questions. And so we're going to go ahead and dive right on in. But please know that there's still time. If you have a question, please go ahead and use your GoToWebinar control panel and submit it. And we'll get to as many as we can. But here's the first one coming at you here. You showed an example of testing a batch programs. Could you elaborate a bit more on possibilities for testing CICS and IMS programs? So Stina, I think that one is for you.
Yeah, I believe so. So I can talk about that. So what you saw in the demo is, as a developer, I generated a test case of this batch program and then I executed it isolated. So that also works for CICS and IMS. So with Topaz for Total Test, you can also kick off an IMS or a CICS transaction, and then from the debug session, you can generate a test case in the exact same way as you did with the batch program. The difference is when you do it with a CICS or IMS program, if you have any API calls to CICS or IMS, these will also be captured by Expediter and saved as a stub. So, and the really good thing here is when you execute the test case, it will not require any CICS or IMS environment. It will actually just be running as a batch job, virtualizing not only data access subprograms, but also virtualizing the whole CICS or IMS environment. And this is, so just one more thing about that, it also covers green screen testing. So if you have a green screen, you can test the program behind. And it also covers IMS MPP programs. So I hope that answers the question.
Okay, great. Next question. Do we have a tool, or is there a tool that readily displays the 3 metrics: lead time, change, fail, and availability?
I will take that. So that is something that through the XebiaLabs release orchestration dashboards is something that you can add on a folder level and in the individual release level as well. So the answer to that is yes.
Okay. All right, great. Next question. Let's see. Do we get Compuware DevOps products to perform POC, or can Compuware's DevOps products perform POC?
Yeah, this is Mark. I mean, if you want to go and try these out, yes, you can talk to your Compuware representative, and we can then arrange for you to try them out either on site, or we also have test drive where you can go in and use them in realistic scenarios without having to go through installing the products.
Okay, great. I'm sure a lot of people are happy to hear that. So the next question then, kind of along with that, is Total Test a platform from Compuware or a single tool to execute test automation in Mainframe?
Yeah, so I can take that. Now I'm not sure what the person asking what they're meaning with a platform, but I can talk a little bit more about what it is. So it's not just to install the Topaz workbench. You also need a mainframe part to be installed. So it's we call it the TTT runner on the mainframe that will virtualize all the external calls. And then you have on the decentralized side or inside Topaz, you will have the test case and all the stubs. So it is a tool you install, but it also requires some infrastructure. Then now we only looked at unit testing today, but if you look into the functional and integration possibilities in Total Test, I would say then it starts to be maybe more like what you could call a platform, because you actually get a framework to create all kind of test scenarios that you want. That will not include virtualizing data, but it will allow you to make test scenarios where you can combine things like selecting data from DB2, using that data as input to a program. You can submit batch job. You can compare data sets on the mainframe, either by using built-in comparison in Topaz for Total Test, or you can use integration with File Compare. You can validate content of spool files. You can send and receive MQ messages. So you can do basically anything you can do on the mainframe. You can orchestrate that in a very easy way. So yes, you could call that part of the product like a platform that you can use.
Okay. All right. Great. So we're about 5 minutes to the top of the hour. I think we can get to 1 or 2 more questions here. So many good questions that have come in so far. I'm kind of blown away by all the questions that have come in. So let's get to it. I saw 3 development streams. Can we increase this? If yes, what is the maximum number of parallel development streams can be created?
Right, this, Mark, I think you're talking about an ISPW where I had Dev 1, Dev 2, and Dev 3. I don't even know of a limit. Normally, people do 2 or 3. Sometimes they say that they want each developer and their team to have their own. So I've seen them up like 8 or 10 or 12. But then in practice, they kind of fall back and you know what? Really, 3's fine. So I don't think there's a limit. You can have a lot of streams. But in practice, people usually have them low. It's just up to you, and those are quick to create and change at any time.
Okay. All right. Great. Let's see. Next question. Looks like most organizations are moving away from the mainframe. With that, does enabling DevOps for the mainframe, is it helpful to enable DevOps for the mainframe? And I know this is kind of this is a great question. We could do an entire webinar on this question, I know.
Yeah. Can I start on that one? Because
sure.
yeah, so I think this is a false statement. So we just did a worldwide survey of a lot of different mainframe companies across the world. Most companies that already have a mainframe, they, in a 5-year period, they are expecting to move more critical applications to the mainframe, and they are expecting to increase the investment in the mainframe. So I believe it's completely opposite of the question. Companies are actually investing more and more in the mainframe. And so this has changed over the last 10 years. And what has really changed is all the tools and the processes that are now in focus with the DevOps initiative and with the tools like XebiaLabs and Compuware provides. That makes the mainframe a really, really strong platform. And it's basically the difference between the mainframe and the decentral is just syntax. If you're writing COBOL or Java code, it doesn't matter. You have the same kind of tools today and the same kind of processes on the mainframe as well. So there's no need to get off the mainframe.
Okay, anybody else want to chime in on that question?
Yeah, I mean, I think I'd like to just add on that. I completely agree with everything that Steen said in this particular case. But, you know, since so many companies are continuing to use their applications on the mainframe and are increasing their use of the mainframe, the DevOps is really what adds the efficiency and helps you, integrate these processes with everything else. So, you'll see performance improvements across your organization and be able to release more and better software as a result of integrating DevOps.
All right, great. Great. Well, we're about 2 minutes to the top of the hour, so unfortunately we're going to have to close out the question and answer period of today's webinar. But I do want to thank everybody who did submit questions, and please know that everybody who's on this webinar, all of our speakers, will be getting a copy of the questions that came through. So if we didn't get to your question online, please know that they'll be more than happy to follow up with you post-event and get your question answered. I also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, that's fine. You'll be able to do so later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars and look in the on demand section, and it should be right there waiting for you. So Mark, Steen, Scott, and Vincent, thank you all so much for today's presentation. Lots and lots of great stuff. Really appreciate it. I also want to thank the audience for joining me today. And this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Thank you.
Thank you.
Thank you.